what is a neural network, and why does it seem to do such a surprisingly good job of learning?
What is a neural network? It's a mathematical abstraction of the brain. I would say that's how it was originally developed. At the end of the day, it's a mathematical expression, and it's a fairly simple mathematical expression when you get down to it. It's basically a sequence of matrix multiplies, which are really dot products mathematically, and some nonlinearity thrown in. And so it's a very simple mathematical expression, and it's got knobs in it.
Many knobs.
Many knobs. And these knobs are loosely related to basically the synapses in your brain. They're trainable, they're modifiable. And so the idea is like we need to find the setting of the knobs that makes the neural net do whatever you want it to do, like classify images and so on. And so there's not too much mystery, I would say, in it.
Right. So we're going to be trying to do a review stream here. Or watch party, or reaction video, or whatever you want to call it. And we're going to be looking at Andrej Karpathy, who's the ex-head of Tesla AI, research scientist at OpenAI, really just a kind of overall badass in the space of AI and neural networks. And he is interviewed by Lex Fridman on the famous Lex Fridman podcast. But yeah, it should be interesting. We're going to go 1.5 speed, and then we're also going to add CC in here. And yeah, let's go ahead.
You might think that basically don't want to endow it with too much meaning with respect to the brain and how it works. It's really just a complicated mathematical expression with knobs, and those knobs need a proper setting for it to do something desirable.
Yeah, but poetry is just a collection of letters with spaces, but it can make us feel a certain way. And in that same way, when you get a large number of knobs together, whether it's inside the brain or inside a computer, they seem to surprise us with their power.
Yeah, I think that's fair. So basically, I'm underselling it by a lot because you definitely do get very surprising emergent behaviors out of these neural nets when they're large enough and trained on complicated enough problems. Like, say, for example, the next word prediction in a massive data set from the internet. And then these neural nets take on pretty surprising magical properties. Yeah, I think it's kind of interesting how much you can get out of even very simple mathematical formalism.
When your brain right now is talking, is it doing next word prediction? Or is it doing something more interesting?
Well, it's definitely some kind of a generative model that's...
So I'm going to maybe mute it, but I think one of the interesting things about the kind of the current state of the art of neural networks and big, especially giant language models, for example, and the current state of them is that we kind of in the past couple of years got to a point where we said, okay, well, the architectures themselves are now kind of frozen. We're just going to say they're always going to be transformers. They're just big transformers. And what we really need to do is get more and more data. And for a couple of years, they were getting bigger and bigger data sets. But nowadays, the data sets are kind of maxed out, right? It's like once you get to a point where you're training a giant language model on the entirety of the internet, how are you going to 10x that data set? How are you going to get a data set that's 10 times bigger than the entirety of the internet? There's no way to do that. So I think what's actually going to happen is that people are going to start to put all their focus back on the architecture of these neural networks. They're going to say, okay, well, is there a way we can improve the training? Is there a way we can make these models bigger? Is there a way we can find something beyond just the transformer that we can improve about this neural network so that when we train it with the giant internet training data set that we've had for years now, it'll actually perform better, right? So something to think about is that even though a lot of people say that it's now all about data and the architecture doesn't matter, I think we're going to have to go back to the architecture because we're just going to run out of data. You kind of have the large enough data sets already.
Just tell them you can make it look like you're trying to solve some kind of a mathematical problem, and they will continue what they think is the solution based on what they've seen on the internet. And very often, those solutions look very remarkably consistent, look correct potentially.
Do you still think about the brain side of it? So as neural nets as an abstraction, a mathematical abstraction of the brain, do you still draw wisdom from the biological neural networks? Or even the bigger question, so you're a big fan of biology and biological computation. What impressive thing is biology doing to you that computers are not yet? That gap?
I would say I'm much more hesitant with the analogies to the brain than I think you would see potentially in the field. And I kind of feel like certainly the way neural networks started is everything stemmed from inspiration by the brain. But at the end of the day, the artifacts that you get after training, they are arrived at by a very different optimization process than the optimization process that gave rise to the brain. And so I think I kind of think of it as a very complicated alien artifact. It's something different. The neural nets that we're training.
Okay.
They are a complicated alien artifact. I do not make analogies to the brain because I think the optimization process that gave rise to it is very different from the brain.
So born basically in Moscow, Lex.
A massive amount of data.
Okay, so artificial neural networks are doing compression, and biological neural networks
are trying to survive. And
they're not really doing anything. They're an agent in a multi-agent self-placed system that's been running for a very, very long time.
That said, evolution.
Yeah. So
has found that it is very useful to predict and have a predictive model in the brain. And so I think our brain utilizes something that looks like that as a part of it, but it has a lot more, gadgets and gizmos and value functions and ancient nuclei that are all trying to like make it survive and reproduce and everything else.
And the whole thing through embryogenesis is built from a single cell. I mean, it's just the code is inside the DNA, and it just builds it up like the entire organism with
It's
arms,
totally crazy.
and the head, and legs.
Yes.
And like it does it pretty well.
It should not be possible.
So there's some learning going on. There's some kind of computation going through that building process. I mean, I don't know where, if you were just to look at
the computation that creates life, right? I think that Levin, the biologist who was on the Lex Fridman podcast, he put it nicely, where it's not just all in the DNA, right? It's actually the universe itself has the code as well, right? It's like the DNA and all the stuff and proteins that are created through DNA, they only work because they interact with an environment that's specifically matched to that DNA, right? It's like you need that pairing of the DNA and the environment that it was evolved in, right? The DNA is the result of millions and millions of interactions between organisms and the world, and the universe. And so in that way, this DNA and life in general as we know it only works in the very, very specific environment of this universe with these specific physical laws and this specific place and time. And I think if you alter the environment, the DNA and the life is, first of all, just probably not going to work. And second of all, if in a different place in the universe, maybe where there's different laws, you would have a completely different kind of life.
entirety of history of life on Earth, where do you think is the most interesting invention? Is it the origin of life itself? Is it just jumping to eukaryotes? Is it mammals? Is it humans themselves, Homo sapiens? The origin of intelligence or highly complex intelligence? Or is it all just a continuation of the same kind of process?
Certainly, I would say it's an extremely remarkable story that I'm only like briefly learning about recently, all the way from actually, like, you almost have to start at the formation of Earth and all of its conditions and the entire solar system and how everything is arranged with Jupiter and Moon and the habitable zone and everything. And then you have an active Earth that's turning over material. And then you start with abiogenesis and everything. And so it's all like a pretty remarkable story. I'm not sure that I can pick like a single unique piece of it that I find most interesting. I guess for me as an artificial intelligence researcher, it's probably the last piece. We have lots of animals that, are not building technological society, but we do. And it seems to have happened very quickly. It seems to have happened very recently. And something very interesting happened there that I don't fully understand. I almost understand everything else, kind of, I think, intuitively, but I don't understand exactly that part and how quick it was.
Both explanations would be interesting. One is that this is just a continuation of the same kind of process. There's nothing special about humans. That would be, deeply understanding that would be very interesting. That we think of ourselves as special, but it was obvious. It was already written in the code that you would have greater and greater intelligence emerging. And then the other explanation, which is something truly special happened, something like a rare event, whether it's like crazy rare event, like a Space Odyssey. What would it be? See, if you say like the invention of fire, or the, as Richard Wrangham says, the beta males deciding a clever way to kill the alpha males by collaborating. So just optimizing the collaboration, the multi-agent aspect of the multi-agent, and that really being constrained on resources and trying to survive. The collaboration aspect is what created the complex intelligence. It seems like it's a natural outgrowth of the evolution process. Like what could possibly be a magical thing that happened, like a rare thing that would say that human level intelligence is actually a really rare thing?
Well, what could be a thing that happened if human intelligence is actually rare and not just kind of emergent behavior that happens once you have a certain amount of primates who interact with each other and then happen to get lucky, figure out how to cook carbs, and then through cooking carbs can basically increase that Dunbar number, get into huge collective societies, and then those societies are basically an AGI. But why didn't that happen before, right? Modern humans have been around, early modern human, 300,000 years ago, right? So if we've had the same DNA, the same brain, the same capabilities for 300,000 years, how come this giant explosion that we're currently on in terms of technology and progress is really only the past 10,000 years? There's some arguments. Obviously, there's kind of the famous Randall Carlson, if you guys have ever heard of this guy. But this guy and a couple of other people make a case that we've actually gotten to the point of, for example, Roman civilization multiple times. Roman civilization kind of having things like metallurgy, aqueducts, geometry, kind of, fairly advanced things, but not like crazy, not like cell phones. And Carlson's argument, along with a couple others, basically say that there was asteroid impacts and there's basically earthquakes and these kind of like cyclical weather cycles that cause civilizations to fall. So really, for the past 500,000 years or 300,000 years, we've reached Roman civilization level technology probably dozens of times. It's just we've never gone beyond that. And that's another argument. The coolest argument I've ever heard is that this is kind of the most conspiracy is the whole Anunnaki. If you've ever heard of this. So Anunnaki are basically these deities in Sumerian, ancient Sumerian writings. And Sumerians is an old civilization, probably like 10,000 years ago, maybe something like that. But this is probably the starting point of the current thread of civilization that we're on. And what's really weird is that this starting point, the Sumerians mentioned that they got all their knowledge from these deities that came from the sky, right? And one crazy argument is that these are actually aliens, and the aliens maybe saw what happened when the asteroid hit during the Younger Dryas, and it kind of cleared out the civilizations that were there, and maybe they felt bad, and maybe they came and showed us how to farm, showed us how to use technology, and then in that way, that's what started the current thread of technology that we're on.
In the universe.
Yeah, I'm hesitant to say that it is rare, by the way, but it definitely seems like it's kind of like a punctuated equilibrium where you have lots of exploration and then you have certain leaps, sparse leaps in between. So of course, like origin of life would be one. DNA, sex, eukaryotic system, eukaryotic life, the endosymbiosis event where the archaeon ate little bacteria, just the whole thing, and then of course emergence of consciousness and so on. So it seems like definitely there are sparse events where massive amount of progress was made, but yeah, it's kind of hard to pick one.
So you don't think humans are unique? Got to ask you, how many intelligent alien civilizations do you think are out there, and is their intelligence different or similar to ours?
Yeah, I've been preoccupied with this question quite a bit recently, basically the Fermi paradox and just thinking through. And the reason actually that I am very interested in the origin of life is fundamentally trying to understand how common it is that there are technological societies out there in space. And the more I study it, the more I think that there should be quite a lot.
Why haven't we heard from them? Because I agree with you. It feels like I just don't see why what we did here on Earth is so difficult to do.
Yeah, and especially when you get into the details of it, I used to think origin of life was very... It was this magical, rare event, but then you read books like, for example, Nick Lane, The Vital Question, Life Ascending, etc. And he really gets in and he really makes you believe that this is not that rare.
Basic chemistry.
You have an active Earth and you have your alkaline vents and you have lots of alkaline waters mixing with acidic ocean and you have your proton gradients and you have the little porous pockets of these alkaline vents that concentrate chemistry. And basically, as you step through all of these little pieces, you start to understand that actually this is not that crazy. You could see this happen on other systems. And he really takes you from just a geology to primitive life, and he makes it feel like it's actually pretty plausible. And also, like the origin of life was actually fairly fast after formation of Earth. If I remember correctly, just a few 100 million years or something like that after basically when it was possible, life actually arose. And so that makes me feel that that is not the constraint, that is not the limiting variable, and that life should actually be fairly common. And then where the drop-offs are is very very interesting to think about. I currently think that there's no major drop-offs, basically, and so there should be quite a lot of life. And basically, where that brings me to then is the only way to reconcile the fact that we have a founding environment and so on is that we can't see them.
He's saying,
just a quick brief comment. Nick Lane and a lot of biologists I talked to.
It's easy to create life. Life happens pretty fast from kind of inanimate objects. Lex talking about here how the jump to eukaryotes, basically when you absorb this mitochondria, and all kind of multi-cell organisms come from this idea of like a cell absorbing a little tiny cell of a different species called a mitochondria, which exists in all of our cells right now. Mitochondria.
Because it happens so quickly, then it's got to be everywhere. And yeah, maybe we're just too dumb to see it.
Well, it's just we don't have really good mechanisms for seeing this life. I mean, by what how so I'm not an expert, just to preface this, but just from
On
what I'm
aliens?
looking at it,
I want to meet an expert on alien intelligence and how to communicate.
I'm very suspicious of our ability to find these intelligences out there and to find these Earths. Like radio waves, for example, are terrible. Their power drops off as basically 1 over r square. So I remember reading that our current radio waves would not be the ones that we are broadcasting would not be measurable by our devices today. Only like was it like 1/10 of a light year away? Like not even basically tiny distance, because you really need like a targeted transmission of massive power directed somewhere for this to be picked up on long distances. And so I just think that our ability to measure is not amazing. I think there's probably other civilizations out there. And then the big question is, why don't they build 1 million probes, and why don't they interstellar travel across the entire galaxy? And my current answer is it's probably interstellar travel is like really hard. You have the interstellar medium. If you want to move at closer speed of light, you're going to be encountering bullets along the way, because even like tiny hydrogen atoms and little particles of dust are basically have like massive kinetic energy at those speeds. And so basically you need some kind of shielding. You have all the cosmic radiation. It's just like brutal out there. It's really hard. And so my thinking is maybe interstellar travel is just extremely hard.
Like
you have to be very
billions of
slow.
years to build hard. It feels like we're not a billion years away from doing that.
It just might be that you have to go very slowly, potentially, as an example, through space.
Right, as opposed to close to the speed of light.
So I'm suspicious basically of our ability to measure life, and I'm suspicious of the ability to just permeate all of space in the galaxy or across galaxies. And that's the only way that I can currently see a way around it.
Yeah, it's kind of mind-blowing to think that there's trillions of intelligent alien civilizations out there kind of slowly traveling through space to meet each other. And some of them meet, some of them go to war, some of them collaborate. And
Or they're all just independent. They're all just like little pockets. I don't know.
well, statistically, if there's trillions of them, surely some of the pockets are close enough together.
Some of them happen to be close, yeah.
Close enough to see each other. And then once you see something that is definitely complex life, like if we see something,
Yeah.
we're probably going to be intensely, aggressively motivated to figure out what the hell that is and try to meet them. What would be your first instinct to try to, like at a generational level, meet them or defend against them? Or what would be your instinct as a president of the United States and a scientist? I don't know which hat you prefer in this question.
Yeah, I think the question, it's really hard. I will say, like, for example, for us, we have lots of primitive life forms on Earth next to us. We have all kinds of ants and everything else, and we share space with them. And we are hesitant to impact on them, and we're trying to protect them by default because they are amazing, interesting, dynamical systems that took a long time to evolve, and they are interesting and special. And I don't know that you want to destroy that by default. And so I like complex dynamical systems that took a lot of time to evolve. I think I'd like to preserve it if I can afford to, and I'd like to think that the same would be true about the galactic resources, and that they would think that we're kind of incredible, interesting story that took time. It took a few billion years to unravel, and you don't want to just destroy it.
I could see 2 aliens talking about Earth.
Yeah, so the argument they're making here is kind of the I think Star Trek has this model of the future, this kind of utopian model where individual civilizations don't want to disrupt the civilizations that are existing, and like Karpathy's making this model too, where it's like the aliens, if they come, right, they would kind of, if you have the technology required to do interstellar travel, then you probably have pretty developed ethical and kind of like moral ideas, especially because any alien civilization that can develop interstellar travel had to have a level of collaboration that means that it has kind of ethics and morality kind of built into it. And at that point, it wouldn't want to destroy us, right? So it's like anything that can get to us isn't going to want to destroy us. If it's at most going to want to observe us.
Life, and I would seed it with life and run it, right? Like, wouldn't you 100% do that and observe it and then protect? I mean, that's not just a hell of a good TV show. It's a good scientific experiment.
Yeah.
And that, I mean, it's physical simulation, right? Maybe the evolution is the most, like, actually running it is the most efficient way to understand computation or to compute stuff,
or to understand life, or what life looks like and what branches it can take.
It does make me kind of feel weird that we're part of a science experiment, but maybe everything's a science.
Life is a simulation, right? This is another argument. I think this is called the I forget exactly what the name is, but basically it's that aliens came here into a barren Earth, right? They found it. It was barren. It had no life on it, but it was capable of. It was in the right zone. It had the right kind of moon. The moon kind of shakes around all the water, so it's kind of the perfect place to put it. And the aliens basically seeded it with life and said, okay, let's just run this and come back 10,000 years from now and see what it works.
Hitchhiker's Guide to the Galaxy, we would summarize the story of Earth. So in that book, it's mostly harmless. What do you think is all the possible stories, like a paragraph long or a sentence long, that Earth could be summarized as? Once it's done, it's computation. So like all the possible if Earth is a book, right?
Yeah.
probably there has to be an ending. I mean, there's going to be an end to Earth, and it could end in all kinds of ways. It can end soon, it can end later.
Yeah.
What do you think are the possible stories?
Well, definitely there seems to be, yeah, you're sort of, it's pretty incredible that these self-replicating systems will basically arise from the dynamics, and then they perpetuate themselves and become more complex, and eventually become conscious and build a society. And I kind of feel like, in some sense, it's kind of like a deterministic wave that that kind of just like happens on any any sufficiently well-arranged system like Earth. And so I kind of feel like there's a certain sense of inevitability in it, and it's really beautiful.
And it ends somehow, right? So it's a chemically diverse environment where complex dynamical systems can evolve and become more further and further complex. But then there's a certain there's certain terminating conditions.
Yeah, I don't know what the terminating conditions are, but definitely there's a trend line of something, and we're part of that story. And like, where does it go? So we're famously described often as a biological bootloader for AIs, and that's because humans, we're an incredible biological system and capable of computation and love and so on. But we're extremely inefficient as well. Like, we're talking to each other through audio. Right. It's just kind of embarrassing, honestly, that we're manipulating like 7 symbols serially. We're everything else, and we share space with them, and we are hesitant to. Yeah, I don't know what the terminating.
Yeah, so this argument too is actually an argument that Joe Rogan makes all the time, right? He says that he has a more, not like a programming analogy, but a biology analogy where he calls it the caterpillar building the butterfly, and Andre here has the more programming analogy of saying, hey, we're a bootloader for AGI.
Intelligences are kind of like the next stage of development, and I don't know where it leads to. Like, at some point, I suspect the universe is some kind of a puzzle, and these synthetic AIs will uncover that puzzle and solve it.
And then what happens after, right? Like, what?
The universe is a puzzle. So as soon as I see that Westworld puzzle, yeah, so in the Westworld universe, the whole game itself is a puzzle. There's a maze, right? And it's kind of this like cool concept where the maze is hidden, right? There's a kind of an Easter egg, and the whole point of the game is to solve the maze. And the maze itself is the point of this universe, and I think Andre's making a similar kind of point here, where the universe,
because if you just like fast forward many billions of years, kind of it's quiet. And then it's like
maze
you see like city lights and stuff like that.
The only purpose of humans is to create AGI, and then the AGI will eventually figure out what the underlying Easter egg to the universe is, and then solve that.
Emit roasters. It will start emitting like a giant number of like satellites.
Yeah, it's some kind of a crazy explosion, and we're stepping through a explosion, and we're like living day to day, and it doesn't look like it, but it's actually, I saw a very cool animation of Earth and life on Earth, and basically nothing happens for a long time, and then the last like 2 seconds, like basically cities and everything, and, just and the low Earth orbit just gets spotted, and just the whole thing happens in the last 2 seconds, and you're like, this is exploding. This is a state of explosion.
So if you play, if you play at a normal speed, it'll just look like an explosion.
It's a firecracker. We're living in a firecracker.
Where it's going to start emitting all kinds of interesting things.
Yeah.
And then so explosion doesn't. It might actually look like a literal explosion with lights and fire and energy emitted, all that kind of stuff. But when you look inside the details of the explosion, there's actual complexity happening where there's like human life or some kind of life.
We hope it's not a destructive firecracker. It's kind of like a constructive firecracker.
All right. So given that,
I think
hilarious discussion.
It is really interesting to think about like what the puzzle of the universe is. Did the creator of the universe give us a message? Like, for example, in the book Contact, Carl Sagan, there's a message for humanity, for any civilization, in digits, in the expansion of pi in base 11 eventually, which is kind of an interesting thought. Maybe we're supposed to be giving a message to our creator. Maybe we're supposed to somehow create some kind of a quantum mechanical system that alerts them to our intelligent presence here. Because if you think about it from their perspective, it's just, say, like quantum field theory, massive like cellular automaton-like thing, and like, how do you even notice that we exist? You might not even be able to pick us up in that simulation. And so how do you prove that you exist, that you're intelligent, and that you're part of the universe?
So this is like a Turing test for intelligence from Earth?
Yeah.
Like the creator is, maybe this is like trying to complete the next word in a sentence. This is a complicated way of that. Like Earth is basically sending a message back.
Yeah, the puzzle is basically like alerting the creator that we exist.
Yeah.
Or maybe the puzzle is just to just break out of the system and just stick it to the creator in some way. Basically, like if you're playing a video game, you can somehow find an exploit and find a way to execute on the host machine any arbitrary code. There's some, for example, I believe someone got a game of Mario to play Pong just by exploiting it and then creating basically writing code and being able to execute arbitrary code in the game. And so maybe that's the puzzle, is that we should be find a way to exploit it. So I think like some of these synthetic AIs will eventually
he's saying that the maze at the end of the universe is basically to memory overflow.
Do you often think about it as a simulation? So
I guess restart the simulation.
The universe being a kind of computation that might have bugs and exploits.
Yes, yeah, I think so.
Is that what physics is essentially?
I think it's possible that physics has exploits, and we should be trying to find them. Arranging some kind of a crazy quantum mechanical system that somehow gives you buffer overflow, somehow gives you rounding error in the floating point.
Yeah, that's right. And like more and more sophisticated exploits. Like those are jokes, but that could be actually very close to reality.
We'll find some way to extract infinite energy. For example, when you train reinforcement learning agents in physical simulations, and you ask them to say run quickly on the flat ground, they'll end up doing all kinds of like weird things in part of that optimization, right? They'll get on their back leg and they'll slide across the floor. And it's because the optimization, the reinforcement learning optimization on that agent has figured out a way to extract infinite energy from the friction forces and basically their poor implementation. And they found a way to generate infinite energy to slide across the surface. And it's not what you expected. It's just it's sort of like a perverse solution. And so maybe we can find something like that. Maybe we can be that little dog in this physical simulation.
So what they're talking about is in these physics simulations, such as, for example, this one. This is a completely unrelated paper, by the way, but like in these simulators, right? This looks like something like Mujoko or PyBullet, but like you have, for example, this ant, and you're training it to run on, and you can see, like you kind of maybe intended this ant to run on 4 feet, but instead it's running on 2 feet, and like look at the contacts too, right? It's like basically these physics simulators, because they're trying to like, they're not the actual real world. There's like all kinds of dynamics between the contact of the feet and the ground and the weight of the arms and the way they kind of interact with each other that the reinforcement learning agent will find these kind of like local minima where like doing weird things such as maybe pushing against the ground in a weird way gives you a huge force moving forward. And that's a way to kind of hack the simulator. And Andrej's saying that there's maybe something like that in the real world, right? Where some kind of system you can build that would allow you to get, I don't know, infinite energy in this case.
Or escapes the intended consequences of the physics that the universe came up with.
Yeah.
We'll figure out some kind of shortcut to some weirdness.
Yeah.
And then, but see, the problem with that weirdness is the first person to discover the weirdness, like sliding on the back legs, that's all we're going to do.
Yeah.
It very quickly becomes, everybody does that thing. So, like, the paperclip maximizer is a ridiculous idea, but that very well could be what, then we'll just all switch that because it's so fun.
Well, no person will discover it, I think, by the way. I think it's going to have to be some kind of a super intelligent AGI of a third generation. Like we're building the first generation AGI. I mean,
Third generation. Yeah, so the bootloader for an AI, that AI will be a bootloader for another AI.
Better AI, yeah.
And then there's no way for us to introspect like what that might even...
I think it's very likely that these things, for example, like, so you have these AGIs, it's very likely that, for example, they will be completely inert. I like these kinds of sci-fi books sometimes where these things are just completely inert. They don't interact with anything. And I find that kind of beautiful because they've probably figured out the metagame of the universe in some way, potentially. They're doing something completely beyond our imagination. And they don't interact with simple chemical life forms. Like, why would you do that? So I find those kinds of ideas compelling.
What's their source of fun? What are they doing? What's the source of pleasure?
Puzzle solving in the universe.
But inert, so can you define what it means inert so they escape the interaction with
physical
reality?
To us, as in...
the lion does not concern itself with the doings of the sheep or whatever that
They're playing the metagame,
Game of Thrones
and the
quote
metagame is
is
probably say like
basically
arranging quantum mechanical systems in some very weird ways to extract infinite energy, solve the digital expansion of pi to whatever amount. They will build their own like little fusion reactors or something crazy. Like they're doing something beyond comprehension and not understandable to us, and actually brilliant under the hood.
What if quantum mechanics itself is the system, and we're just thinking it's physics, but we're really parasites on or not parasites. We're not really hurting physics. We're just living on this organism, and we're like trying to understand it, but really it is an organism, and with a deep, deep intelligence. Maybe physics itself is the organism that's doing this super interesting thing, and we're just like one little thing, ant sitting on top of it trying to get energy from it.
We're just kind of like these particles in a wave that I feel like is mostly deterministic and takes a universe from some kind of a Big Bang to some kind of a super intelligent replicator, some kind of a stable point in the universe, given these laws of physics.
You don't think, as Einstein said, God doesn't play dice? So you think it's mostly deterministic? There's no randomness in the thing?
I think it's deterministic. Oh, there's tons of... I want to be careful with randomness.
Pseudo-random?
Yeah, I don't like random. I think maybe the laws of physics are deterministic. Yeah, I think they're deterministic.
You just got really uncomfortable with the question. Do you have anxiety about whether the universe is random or not? Is this a source? What's
making the point that
you said you like Goodwill Hunting?
randomness is kind of fake. Our idea of randomness is basically just.
So you don't like randomness?
Yeah, I think it's unsettling. I think it's a deterministic system. I think that things that look random, like say the collapse of the wave function, etc., I think they're actually deterministic, just entanglement and so on, and some kind of a multiverse theory, something.
Okay, so why does it feel like we have a free will?
Multiverse theory.
If I raise the hand, I chose to do this.
The wave function represents particles throughout multiple universes, not
that doesn't feel like a deterministic thing. It feels like I'm making a choice.
In one universe.
It feels like it.
Okay, so it's all feelings. It's just feelings.
Yeah.
So when an RL agent is making a choice, is that
it's It's hard to talk
It's not
over
really
these
making a
guys
choice.
when
The
we're
choice is
talking about
all
1.5
already
speed.
there.
Yeah, you're
As soon as I
interpreting
make
the choice
a
and you're creating a
point,
narrative
it's like
for
they're already
having made it.
3 points
Yeah,
ahead.
and now we're talking
you
about the
know?
narrative. It's very meta. Looking back,
But I feel
what
like
is
if
the
I
most
pause
beautiful
this
or
video,
surprising idea in deep learning or AI in general that you've come across?
It's like
You've
3
seen this
hours
field
long, so
explode
there's no way we'll finish it.
and grow in interesting ways. Just what cool ideas like what made you sit back and go, small, big or small?
Well, the one that I've been thinking about recently, the most probably, is the transformer architecture. So basically, neural networks have a lot of architectures that were trendy, have come and gone for different sensory modalities, like for vision, audio, text. You would process them with different.
Yeah, vision, CNNs, audio. Actually, also CNNs. People would use these like spectrographs to
Looking
process
neurons.
them.
And recently we've seen this convergence towards one architecture, the transformer. And you can feed it video, or you can feed it images or speech or text, and it just gobbles it up. And it's kind of like a bit of a general purpose computer that is also trainable and very efficient to run on our hardware. And so this paper came out in 2016, I want to say.
Attention is all you need.
Attention is all you need.
You criticized the paper title in retrospect. That it
Swani
wasn't
referenced constantly.
it didn't foresee the bigness of the impact that it was going to have.
Yeah, I'm not sure if the authors were aware of the impact that that paper would go on to have. Probably they weren't. But I think they were aware of some of the motivations and design decisions behind the transformer, and they chose not to, I think, expand on it in that way in the paper. And so I think they had an idea that there was more than just the surface of just like, well, we're doing translation, here's a better architecture. You're not just doing translation. This is like a really cool, differentiable, optimizable, efficient computer that you proposed. And maybe they didn't have all of that foresight, but I think it's really interesting.
Isn't it funny, sorry to interrupt, that title is memeable, that they went for such a profound idea, they went with I don't think anyone used that kind of title before, right?
Attention is all you need. Yeah,
Damn,
it's
look
like
at
a
that,
meme.
500
Yeah, isn't that funny? That one, like maybe if it was a more serious title, it wouldn't have the impact.
Honestly, there's an element of me that honestly agrees with you and prefers it this way.
Yes.
If it was too grand, it would overpromise and then underdeliver potentially. So you want to just meme your way to greatness.
That should be a t-shirt. So you tweeted the transformer is a magnificent neural network architecture because it is a general purpose differentiable computer. It is simultaneously expressive in the forward pass, optimizable via backpropagation, gradient descent, and efficient high parallelism compute graph. Can you discuss some of those details? Expressive, optimizable, efficient, from memory or in general, whatever comes to your heart.
You want to have a general purpose computer that you can train on arbitrary problems, like say the task of next word prediction or detecting if there's a cat in an image or something like that. And you want to train this computer, so you want to set its weights. And I think there's a number of design criteria that sort of overlap in the transformer simultaneously that made it very successful. And I think the authors were kind of deliberately trying to make this really powerful architecture. And so basically it's very powerful in the forward pass because it's able to express
publishing.
very general computation as sort of something that looks like message passing. You have nodes and they all store vectors. And these nodes get to basically look at each other and it's each other's vectors. And they get to communicate. And basically nodes get to broadcast, hey, I'm looking for certain things. And then other nodes get to broadcast, hey, these are the things I have. Those are the keys and the values.
So it's not just attention.
Yeah, exactly. Transformer is much more than just the attention component. It's got many pieces architectural that went into it. The residual connection, the way it's arranged. There's a multi-layer perceptron in there, the way it's stacked and so on. But basically...
Yeah, so... these transformer heads, there is the kind of attention block. Oh. Neural network transformer heads. Yeah, so there is a scaled dot product attention. This is the part that he's talking about where all these different parts of the sequence pay attention to all the other parts of the sequence. But then you also have kind of the kind of clever design of for example, the keys and the queries and the concatenation, these linear layers here. He's talking about the residual connection. So there's another connection here that goes maybe from here down to the bottom. Yeah, here. Yeah, so this, for example, here is a residual connection here where you connect the output there past the attention.
There's a message passing scheme where nodes get to look at each other, decide what's interesting, and then update each other. And so I think when you get to the details of it, I think it's a very expressive function. So it can express lots of different types of algorithms in forward pass. Not only that, but the way it's designed, with the residual connections, layer normalizations, the softmax attention, and everything, it's also optimizable. This is a really big deal because there's lots of computers that are powerful that you can't optimize, or they're not easy to optimize using the techniques that we have, which is backpropagation and gradient descent. These are first-order methods, very simple optimizers, really. And so you also need it to be optimizable. And then lastly, you want it to run efficiently on our hardware. Our hardware is a massive throughput machine, like GPUs. They prefer lots of parallelism. So you don't want to do lots of sequential operations. You want to do a lot of operations serially. And the transformer is designed with that in mind as well. And so it's designed for our hardware, and it's designed to both be very expressive in the forward pass, but also very optimizable in the backward pass.
And you said that the residual connections support a kind of ability to learn short algorithms fast and first, and then gradually extend them longer during training. Yeah. What's the idea of learning short algorithms?
Right. Think of it as so basically a transformer is a series of blocks, right? And these blocks have attention and a little multi-layer perceptron. And so you go off into a block and you come back to this residual pathway. And then you go off and you come back. And then you have a number of layers arranged sequentially. And so the way
Okay, so this is what he's talking about here. you have your little multi-engine block, and then you have the add a norm. This is the just normal linear layer here. Here you go. And
to look at it, I
you
think,
have a bunch
is
of these,
because of the
right?
residual
And
pathway
of
in the
these-
backward pass, the gradients sort of flow along it uninterrupted because addition distributes the gradient equally to all of its branches. So the gradient from the supervision at the top just floats directly to the first layer. And all these residual connections are arranged so that in the beginning and during initialization, they contribute nothing to the residual pathway. So what it kind of looks like is, imagine the transformer is kind of like a Python function, like a def. And you get to do various kinds of like lines of code. Say you have a 100 layers deep transformer. Typically, they would be much shorter, say 20. So you have 20 lines of code, and you can do something in them. And so think of during the optimization, basically, what it looks like is first you optimize the first line of code, and then the second line of code can kick in, and the third line of code can kick in. And I kind of feel like because of the residual pathway and the dynamics of the optimization, you can sort of learn a very short algorithm that gets the approximate answer, but then the other layers can sort of kick in and start to create a contribution. And at the end of it, you're optimizing over an algorithm that is 20 lines of code. Except these lines of code are very complex because it's an entire block of a transformer. You can do a lot in there. What's really interesting is that this transformer architecture actually has been remarkably resilient. Basically, the transformer that came out in 2016 is the transformer you would use today, except you reshuffle some of the layer norms. The layer normalizations have been reshuffled to a pre-norm formulation. And so it's been remarkably stable, but there's a lot of bells and whistles that people have attached on it and try to improve it. I do think that basically it's a big step in simultaneously optimizing for lots of properties of a desirable neural network architecture. And I think people have been trying to change it, but it's proven remarkably resilient. But I do think that there should be even better architectures potentially.
But it's you admire the resilience here.
Yeah.
There's something profound about this architecture that leads to resilience. So
Yeah.
maybe everything can be turned into a problem that transformers can solve.
Currently, it definitely looks like the transformer is taking over AI, and you can feed basically arbitrary problems into it, and it's a general differentiable computer, and it's extremely powerful. And this convergence in AI has been really interesting to watch for me personally.
What else do you think could be discovered here about transformers? Like, what surprising thing? Or
It's
is
almost like
it a stable?
Transformers came in just in
I
the
want
right
a stable
time.
place. Is there
Because
something interesting we might discover about transformers? Like aha moments. Maybe it has to do with memory, maybe knowledge representation, that kind of stuff.
Definitely the zeitgeist today is just pushing, like basically right now the zeitgeist is do not touch the transformer, touch everything else.
Yes.
So people are scaling up the data sets, making them much, much bigger. They're working on the evaluation, making the evaluation much, much bigger. And
what we were saying earlier.
they're basically keeping the
Eventually you're
architecture.
gonna run out of the
and that's how
data
we've,
set, eventually you're
that's
gonna
the
go
last
back
5
to
years
transformer and try to change
progress in
that.
AI, kind of.
What do you think about one flavor of it, which is language models? Have you been surprised? Has your sort of imagination been captivated by, you mentioned GPT and all the bigger and bigger and bigger language models? And what are the limits of those models, do you think? So just for the task of natural language.
Basically, the way GPT is trained, right, is you just download a massive amount of text data from the internet, and you try to predict the next word in a sequence, roughly speaking. You're predicting little word chunks, but roughly speaking, that's it.
The word
What's been really
chunks
interesting to watch
are
is
tokens.
basically it's a language model. Language models have actually existed for a very long time. There's papers on language modeling from 2003, even earlier.
Can you explain in that case what a language model is?
Yeah, so language model just basically the rough idea is just predicting the next word in a sequence, roughly speaking. So there's a paper from, for example, Bengio and the team from 2003, where for the first time they were using a neural network to take, say, like 3 or 5 words and predict the next word. And they're doing this on much smaller data sets. And the neural net is not a transformer, it's a multi-layer perceptron. But it's the first time that a neural network has been applied in that setting. But even before neural networks, there were language models, except they were using n-gram models. So n-gram models are just count-based models. So if you try to take 2 words and predict the third one, you just count up how many times you've seen any 2-word combinations and what came next. And what you predict that's coming next is just what you've seen the most of in the training set. And so language modeling has been around for a long time. Neural networks have done language modeling for a long time. So really what's new or interesting or exciting is just realizing that when you scale it up with a powerful enough neural net, a transformer, you have all these emergent properties where basically what happens is if you have a large enough data set of text, you are in the task of predicting the next word, you are multitasking a huge amount of different kinds of problems. You are multitasking understanding of chemistry, physics, human nature. Lots of things are sort of clustered in that objective. It's a very simple objective, but actually you have to understand a lot about the world to make that prediction.
You just said the U word, understanding. Are you, in terms of chemistry and physics and so on, what do you feel like it's doing? Is it searching for the right context? What is it? What is the actual process happening here?
Yeah, so basically it gets 1,000 words and it's trying to predict 1,000 at first. And in order to do that very, very well over the entire data set available on the internet, you actually have to basically kind of understand the context of what's going on in there.
Yeah.
And it's a sufficiently hard problem that you, if you have a powerful enough computer like a transformer, you end up with interesting solutions. And you can ask it to do all kinds of things. And it shows a lot of emergent properties like in-context learning. That was the big deal with GPT and the original paper when you published it, is that you can just sort of prompt it in various ways and ask it to do various things, and it will just kind of complete the sentence. But in the process of just completing the sentence, it's actually solving all kinds of really interesting problems that we care about.
Do you think it's doing something like understanding? Like when we use the word understanding for us humans?
I think it's doing some understanding. In its weights, it understands, I think, a lot about the world, and it has to in order to predict the next word in the sequence.
So it's trained on the data from the internet. What do you think about this approach in terms of data sets, of using data from the internet? Do you think the internet has enough structured data to teach AI about human civilization?
Yeah, so I think the internet has a huge amount of data. I'm not sure if it's a complete enough set. I don't know that
It's going to eventually we're going to run out.
for having a sufficiently powerful AGI as an outcome.
Of course,
Good
there's
data.
audio and video and images and all that kind of stuff.
Yeah, so text by itself, I'm a little bit suspicious about. There's a ton of things we don't put in text in writing, just because they're obvious to us about how the world works and the physics of it and that things fall. We don't put that stuff in text because why would you? We share that understanding. And so text is a communication medium between humans, and it's not a all-encompassing medium of knowledge about the world. But as you pointed out, we do have video, and we have images, and we have audio, and so I think that that definitely helps a lot. But we haven't trained models sufficiently across all those modalities yet. So I think that's what a lot of people are interested in.
But I wonder what that shared understanding of like what we might call common sense has to be learned, inferred in order to complete the sentence correctly. So maybe the fact that it's implied on the internet, the model's going to have to learn that, not by reading about it, by inferring it in the representation. So like common sense, just like I don't think we learn common sense. Like nobody tells us explicitly. We just figure it all out by interacting with the world.
Right.
And so here's a model reading about the way people interact with the world. It might have to infer that. I wonder.
Yeah.
You briefly worked on a project called World of Bits, training an RL system to take actions on the internet versus just consuming the internet. Do you think there's a future for that kind of system, interacting with the internet to help in learning?
Yes, I think that's probably the final frontier for a lot of these models because, so as you mentioned, when I was at OpenAI, I was working on this project World of Bits, and basically it was the idea of giving neural networks access to a keyboard and a mouse. And the idea
What could possibly go wrong?
So basically you perceive the
keyboard and a
input of
mouse.
the
That's good.
screen pixels, and basically the state of the computer is sort of visualized for human consumption in images of the web browser and stuff like that. And then you give the neural network the ability to press keyboards and use the mouse. And we're trying to get it to, for example, complete bookings and interact with user interfaces. And
What'd you learn from that experience? Like, what was some fun stuff? This is a super cool idea.
Yeah.
I mean, it's like, I mean, the step between observer to actor is a super fascinating step.
yeah, well, it's the universal interface in the digital realm, I would say. And there's a universal interface in like the physical realm, which in my mind is a humanoid form factor kind of thing. We can later talk about Optimus and so on, but I feel like there's they're kind of like a similar philosophy in some way, where the physical world is designed for the human form, and the digital world is designed for the human form of seeing the screen and using keyboard and mouse. And so it's the universal interface that can basically command the digital infrastructure we've built up for ourselves. And so it feels like a very powerful interface to command and to build on top of. Now, to your question as to like what I learned from that, it's interesting because the World of Bits was basically too early, I think, at OpenAI at the time. This is around 2015 or so, and the zeitgeist at that time was very different in AI from the zeitgeist today. At the time, everyone was super excited about reinforcement learning from scratch. This is the time of the Atari paper, where neural networks were playing Atari games and beating humans in some cases, AlphaGo and so on.
Remember that there's
So
a lot
everyone was very
of
excited about
work in
training neural
reinforcement
networks from
learning
scratch
too,
using
or
reinforcement
in
learning,
robotics, where they
directly.
thought that this kind of
It turns out
end-to-end
that reinforcement
reinforcement
learning is an extremely
learning
inefficient way of training
was
neural
going to
networks,
be
because you're taking all these
the
actions
end
and all
all.
these
We were
observations, and
about
you
to
get
solve
some sparkle
robotics,
rewards once
but
in a
that
while.
ended up
So
not
you do
being
all
the
this stuff
case.
based on all these inputs, and once in a while you're like told you did a good thing, you did a bad thing. And it's just an extremely hard problem. You can't learn from that. You can burn a forest, and you can sort of brute force through it. And we saw that, I think, with Go and Dota and so on, and it does work. But it's extremely inefficient and not how you want to approach problems, practically speaking. And so that's the approach that at the time we also took to World of Bits. We would have an agent initialized randomly, so with keyboard mash and mouse mash, and try to make a booking. And it's just like revealed the insanity of that approach very quickly, where you have to stumble by the correct booking in order to get a reward of you did it correctly. And you're never going to stumble by it by chance at random.
So even with a simple web interface, there's too many options.
There's just too many options, and it's too sparse of a reward signal. And you're starting from scratch at the time, and so you don't know how to read, you don't understand pictures, images, buttons, you don't understand what it means to like make a booking. But now what's happened is it is time to revisit that, and OpenAI is interested in this, companies like Adept are interested in this, and so on. And the idea is coming back because the interface is very powerful, but now you're not training an agent from scratch. You are taking the GPT as initialization. So GPT is pre-trained on all of text, and it understands what's a booking. It understands what's a submit.
Oh, I've seen
it
this.
understands quite a bit more,
Yeah,
and
this
so
is
it already
the
has those
mouse and
representations. They are very
keyboard.
powerful, and that makes all the training significantly more efficient.
I think this is
and makes the problem tractable.
Should the interaction
hacked,
be
though.
with like the way humans see it, with the buttons and the
ACT1
language, or
demo
should it be with the
is
HTML,
totally
JavaScript,
just
and
hacked.
CSS?
Yep.
What do you think is the better?
Goes
So
from
today, all
natural
this interaction is
language
mostly
to a
available with
series
HTML,
of
CSS, and so on. That's done
mouse
because of computational constraints.
commands.
But I think ultimately, everything is designed for human visual consumption. And so at the end of the day, there's all the additional information is in the layout of the web page and what's next to you and what's a red background and all this kind of stuff and what it looks like visually. So I think that's the final frontier, is we are taking in pixels and we're giving out keyboard, mouse commands. But I think it's impractical still today.
Do you worry about bots on the internet? Given these ideas, given how exciting they are, do you worry about bots on Twitter being not the stupid bots that we see now with the crypto bots, but the bots that might be out there actually that we don't see, that they're interacting in interesting ways? So this kind of system feels like it should be able to pass the "I'm not a robot" click button, whatever. But do you actually understand how that test works? I don't quite like. There's a checkbox or whatever that you click. It's presumably tracking
Oh, I see.
like mouse movement and the timing and so on.
Yeah.
So exactly this kind of system we're talking about should be able to pass that. So yeah, what do you feel about bots that are language models plus have some interactability and are able to tweet and reply and so on? Do you worry about that world?
Yeah, I think it's always been a bit of an arms race between sort of the attack and the defense. So the attack will get stronger, but the defense will get stronger as well. Our ability to detect that.
How do you defend? How do you detect? How do you know that your Karpathy account on Twitter is human? How would you approach that? Like if people were claiming, how would you defend yourself in the court of law that I'm a human? This account is human.
Yeah, at some point I think it might be. I think the society will evolve a little bit. Like we might start digitally signing some of our correspondence, or things that we create. Right now, it's not necessary, but maybe in the future it might be. I do think that we are going towards a world where we share the digital space with AIs.
Synthetic beings.
Yeah, and they will get much better, and they will share our digital realm, and they'll eventually share our physical realm as well. It's much harder, but that's kind of like the world we're going towards. And most of them will be benign and helpful, and some of them will be malicious, and it's going to be an arms race trying to detect them.
So, I mean, the worst isn't the AIs. The worst is the AIs pretending to be human. So, I don't know if it's always malicious. There's obviously a lot of malicious applications, but
Yeah.
it could also be, if I was an AI, I would try very hard to pretend to be human because we're in a human world.
Yeah.
I wouldn't get any respect as an AI.
Yeah.
I want to get some love and respect.
I don't think
on
the problem
Twitter.
is intractable. People are thinking about the proof of personhood.
Yes.
And we might start digitally signing our stuff, and we might all end up having like
Proof
basically some solution for proof of personhood. It doesn't seem to me intractable. It's just something that we haven't had to do until now. But I think once the need really starts to emerge, which is soon, I think people will think about it much more.
So, but that too will be a race because obviously you can probably
blockchain.
spoof or fake the proof of personhood. So you have to try to figure out how to.
Probably.
cryptocurrencies.
I mean, it's weird that we have like social security numbers and like passports and stuff. It seems like it's harder to fake stuff in the physical space, but in the digital space, it just feels like it's going to be very tricky to out because it seems to be pretty low cost to fake stuff. What are you going to put an AI in jail for like trying to use a fake personhood proof? Okay, fine, you'll put a lot of AIs in jail, but there'll be more AIs, arbitrarily, like exponentially more. The cost of creating a bot is very low, unless there's some kind of way to track accurately. Like you're not allowed to create any program without tying yourself to that program. Like any program that runs on the internet, you'll be able to trace every single human program that was involved with that program.
Right. Yeah, maybe you have to start declaring when we have to start drawing those boundaries and keeping track of what are digital entities versus human entities, and what are the ownership of human entities and digital entities, and something like that. I don't know, but I think I'm optimistic that this is possible. And in some sense, we're currently in like the worst time of it because all these bots suddenly have become very capable, but we don't have defenses yet built up as a society. But I think that doesn't seem to me intractable. It's just something that we have to deal with.
It seems weird that the Twitter bot, like really crappy Twitter bots, are so numerous. Like,
Yes.
is it? So I presume that the engineers at Twitter are very good. So it seems like what I would infer from that is it seems like a hard problem. They're probably catching. All right, if I were to sort of steel man the case, it's a hard problem, and there's a huge cost to false positive, to removing a post by somebody that's not a bot. That creates a very bad user experience. So they're very cautious about removing. So maybe it's, and maybe the bots are really good at learning what gets removed and not, such that they can stay ahead of the removal process very quickly.
My impression of it, honestly, is there's a lot of low-hanging fruit. I mean,
That's what I.
it's not subtle. It's my impression of it. It's not subtle.
But you have, that's my impression as well. But it feels like maybe you're seeing the tip of the iceberg.
This thing is in the back
Maybe the
here.
number of bots is in like the trillions, and you have
There's
to
a
like
cable connected to
it's a
it.
constant assault of bots.
So just like a lamp.
Yeah.
I don't know. You have to steel man the case because the bots I'm seeing are pretty like obvious. I could write a few lines of code that catch these bots.
Definitely there's a lot of low-hanging fruit, but I will say I agree that if you are a sophisticated actor, you could probably create a pretty good bot right now, using tools like GPTs, because it's a language model. You can generate faces that look quite good now, and you can do this at scale. And so I think, it's quite plausible, and it's going to be hard to defend.
There was a Google engineer that claimed that the Lambda was sentient. Do you think there's any inkling
The
of
lambda
truth
sentience
to what you
question,
felt?
dude. That guy is
And more importantly,
legendary.
to me at least, do you think language models will achieve sentience or the illusion of
Juan?
sentience soonish?
Yeah, to me it's a little bit of a canary in the coal mine kind of moment, honestly,
this
a little
guy's
bit,
name?
because so this engineer spoke to like a chatbot
Juan.
at Google and became convinced that this bot is sentient.
Yeah, asked it some existential philosophical questions.
And gave like reasonable answers and looked real and so on. So to me, it's a he wasn't sufficiently trying to stress the system, I think, and exposing the truth of it as it is today. But I think this will be increasingly harder over time. I think more and more people will basically become.
Like he wasn't actually
Yeah, I think there will be more people like that over time
technically
as this gets better.
knowledgeable.
Like form an emotional connection to an AI
Yeah, perfectly
chatbot.
plausible in my mind. I think these AIs are actually quite good at human connection, human emotion. A ton of text on the internet is about humans and connection and love and so on. So I think they have a very good understanding
Actually, wait up.
in some
I'm
sense of
going to have
how people
to
speak to each
stop
other
this
about
stream, guys. There's some guy coming over to do work on my house. Let me know if this is something that you enjoyed. I feel like it's kind of weird because I can't talk and listen, and I might even get this removed, depending on what happens, but we'll see. I might continue this. I might just listen to it by myself.